Hi guys, we've been solving equations, but sometimes in math and in life, things are not equal. What we know about the quantities might be that one is less than the other, or one is greater than the other, or less than or equal, or greater than or equal. And when we know those things rather than an equal relationship, then we set up an inequality. And these come up in science, engineering, economics, finance, anywhere where math is used, you will have inequalities. And so we need to be able to deal with those. And let's take a look. Okay, so solving inequalities is a lot like solving equations. Solving an equation means finding the value or values of a variable that make the equation true. Solving an inequality means finding the value or values of the variable that makes the inequality true. Usually there are many such values, and we specify them using symbols, and we often graph them. So, just reviewing the symbols, first of all, you have less than. The less than symbol is like that, greater than. Then you can also have less than or equal, or greater than or equal. Okay? I always remember that, this symbol has one end. On the left there's one end, but on the right there are two for the less than symbol. And the two ends go to the greater number. And that's the way I remember it. Okay, so let's look at these examples. We want to solve each inequality. We're going to find the values of n for which it is true. So this one we want to get n by itself. We use similar operations that we use for equations, but there are some important differences. To get n by itself here, so that we can have an expression that tells us which values of n makes this true, we'll add 17 to both sides, just like we would with an equation. So take negative 16 plus 17, n minus 17 plus 17. Add it to both sides. On the left we get 1. On the right we get n, so 1 is greater than or equal to n. And we'll usually turn this around. It reads a little better, say n is less than or equal to 1. We swap the n with the 1 and also change the direction of the symbol. So now it says n is less than or equal to 1. Those are the values of n that should make this true. So let's graph it. So I'm going to bring up a number line. We just color in the number line. We color in the parts of the number line corresponding to the values that make it true. So here's our number line. And we'll color in a dot for the, got the number line gone. Sorry about that. Put in a dot for the 1. And then color in everything to the left, because we said n is less than or equal to 1. So we color in the 1, showing 1 is graphed. 1 is a solution. And we also color the rest of the line to the left, because n less than or equal to 1, all the ones less than, satisfy the inequality. They make it true. So we just shade them all in. Everything to the left of 1, and including 1, because it's less than or equal. Okay, so we'll look at the next one. So we want to get v by itself. So we say we're going to divide by both sides by -5, just like we would for an equation. But we have an extra step we have to do. When you multiply or divide by a negative number, you have to reverse the sign, so the symbol, that is. So it's greater than, and we're going to reverse it to less than when we divide by -5. So we take -5v and 30, divide them both by -5. And I like to wait until the end to write the symbol in. That way I don't forget. That's my little mental trick. Wait till the end to remind myself, okay, do I reverse this or not? This time I do reverse it because I divided by -5. And so instead of greater than, it's less than. So we have v on the left less than -6. Okay, that's those are the solutions. All the v's less than -6. Okay, so let's look at that. So there's our number line. And -6 is not included. So we put a circle instead, and we want everything to the left, so we color in to the left. So we want all the v's less than -6. We color them in, but 6 itself is not included because it's not less than or equal. It's just less than. So that's what that looks like. Now obviously, there are a lot of solutions to these, and we can't check them all like we could with equations where we might get 1 or 2 solutions. Just to give yourself an idea, am I on the right track? Does it look reasonable? You could pick a number. For example, we could take -7, plug it in for v. So -5 times -7 is 35. And 35 is greater than 30. So -7, our graph says that it's a solution, and it is. It makes the inequality true because 35 is greater than 30. And it also just kind of barely makes it true, and that looks reasonable. Now 6 should barely make it false. So we take the 6 and put in, I'm sorry, -6 should barely make it false. So we put in -6, -5 times -6 is 30. That would say 30 is greater than 30. It doesn't work. It almost does, though. And so that's pretty encouraging. We're probably correct. -7 worked. -6 was close to working. And we have it as the greatest point that won't work. Anything less than -6 in our graph will work. Okay, so let's look at the next one. So here we have to do a couple steps, right? We're going to solve for x, find the x's that make this true. We need to get rid of this 3 and this 8. We can't deal with the 8 yet, right? It's sort of in parentheses on top here. Remember, the bar is a grouping symbol. Instead, we get rid of the 3, so we'll multiply both sides by 3. Oh, I did what I said I don't do. I went ahead and wrote in that sign. I might make a mistake if I do that. So we'll wait till the end to put the sign in. And we took both sides times 3. Now we say, do we reverse the sign? Well, no, because we're multiplying by a positive. We reverse it when we multiply or divide by a negative. So the sign stays the same. I'm just emphasizing this. Just make yourself conscious of that sign. The direction of the greater than or less than symbol. So this is 8 plus x greater than 21. Made that awfully big. Make that a little bit bigger. Now we're going to squeeze this in here a little bit. Subtract 8 from both sides, and we have x greater than 13. And that's it. So let's take a look at that graph, see what it looks like. There's the graph. We don't include 13, so we use a circle. We color in everything to the right. Okay. And we could test 13, sort of the border point. Put in 13 for x. 8 plus 13 would be 21. Divided by 3 is 7. 7 greater than 7 is false. 7 is not greater than 7. So 13 does not satisfy this, but it almost does. It's right on the borderline, right? If it's just a little bit bigger, anything a little bit bigger than 7 would work. I'm sorry, anything a little bit bigger than 13 would make the left hand a little bit bigger than 7. So just a little bigger, and then you would have a numerator larger than 21 divided by 3 would be greater than 7. So, you can sort of think about it that way and check them. But of course, you cannot plug in all these numbers to verify. Okay, let's look at another one. Okay, so this one has a few more steps. First thing we do is distribute, of course. Okay, so it's negative 2w, negative 2 times negative 7 is 14, plus 3 is greater than w minus 1. Oh, I wrote 4, should be 14. Okay, now we combine our like terms, 14 and 3. Negative 2w plus 17 greater than w minus 1. We got to get our w's to the same side. We'll add 2w to both sides. Add 2w to the left, it goes away, just leaves the 17. Add 2w to the right, you get 3w. And the minus 1 is still there. Okay, then we'll go ahead and add 1 to both sides to get that. So that we'll have 3w by itself. So that gives us 18 is greater than 3w. Divide both sides by 3. We'll take 18, and these always take a lot of room. I'm going to try to, I have to graph it. I have to have room to graph it, so I can do that though. I'm going to continue way up here, and hopefully I won't be in the way of the graph. Okay, so we'll take 18, we're going to divide by 3, and on the other side we're going to take 3w, we're going to divide by 3. But what's the sign? What's the direction of this symbol? Which way does it go? Well, it's not a negative, so we don't change it. Okay, it's still greater than. Okay, so on the left we have 6 greater than w, and that's it. And we'll change it though to say w less than 6. Okay. Okay. So let's graph it. And I was afraid of that. The number line covered it up. Yeah, let's change that then. We got to move that stuff. That won't take long. Okay, let's go there. Let's see, back to... Yeah, here we go. We can actually do something really cool here. We can just lasso this. And let's just move it way over here. It's going to look a little silly, but I think that's far enough. And now we'll just draw this arrow way over here. Got to improvise. Okay, so we finished it up. Our answer's way over here. W less than 6. Now we can draw our number line. And it's less than 6, so 6 is not included, so we draw a circle. And we're going to color to the left or the right. We want to shade everything that's less than 6, right? So that's everything to the left. There it is. Okay. Let's look at the next one. Okay, so this one's kind of big and involved. First thing we got to do, we're not going to change anything. We're just going to distribute what's on the right. So that's negative 8x minus 40. Okay, and then, boy, look at that. Negative 8x, negative 8x. We've seen this kind of thing before. What are they up to? Well, let's add 8x to both sides. So you got negative 40 minus 8x plus 8x. That's greater than or equal to negative 8x minus 40. We'll add the 8x on the end. So all we did was just add 8x to both sides. On the left, it goes away. It leaves negative 40. On the right, it goes away too, right? Negative 8x here plus 8x, that's 0, so you got negative 40. So we have similar things like this that happen with equations, right? We get to the end and we get a statement with just constants, no variables. Well, there's no variable there, so you can tell, is that always true or is it always false? There's no variable, so it's either going to be always true or always false. And this time, this is always, which is it? It's always true, because it says negative 40 greater than or equal to negative 40. Well, negative 40 is equal to negative 40, so it is greater than or equal. So the answer is all real numbers, which we can write like that. This is always true, so any value of x we choose, this is going to be true. Remember, this is like equations. We followed the rules of algebra and the rules that apply to inequalities, that is. And so the solution set's the same for these inequalities, for all of them. And so the solution set for the last one is all real numbers. That means the solution set for the first one is all real numbers. This is true for any value of x. So let's graph that. Simple to graph. There's our number line. And all real numbers, you just color in the whole thing. Okay? And that's it. Okay, so now we're going to look at some compound inequalities. And so those are the ones that have more than one inequality combined with or they could be combined with and. So we're just going to look at a couple of these. I think that's all we got. Yeah. And, well, I've spoiled the drama because I didn't make them disappear. There, they're gone now. So let's take a look. We have here that v over 10 is less than or equal to -1, or negative 5v is less than or equal to -20. So we want the values of v that makes either one of these true. Okay? And that's what we're going to graph. We're going to find all the values and then we're going to graph them. So you just work with each of these individually. First one, multiply both sides by 10 to get the v by itself, right? And that gives us v less than or equal to -1. Okay. And then we do the same thing with the one on the right. We take, we're going to divide both sides by -5, right? I'll wait to write the symbol. I didn't do it on the other side. I should have. It was a positive number, though, that we multiplied by, right? So we do not change the direction of the sign. So divide both sides by -5. We stop and think, oh, we divided by a negative. We must turn that around. It was less than or equal. It becomes greater than or equal. Okay. And so we get v greater than or equal to -20 by my -5, which is 4. So those are the solutions. V less than or equal to -1, or v greater than or equal to -4. Okay. So let's graph them. There's our number line. I did not label all the little marks, but we got -10 and we got 4. Those are the numbers that matter. And those we want less than or equal to -1. Well, that's that. We color it, or oh, -10. I wrote this wrong. -10 is what it should be. Less than or equal to -10. So we color in the -10 and everything to the left because it's less than or equal. And we want greater than or equal to -4, so we color that in, including the -4. It's a dot instead of a circle because the I think I said -4. It's 4, right? Greater than or equal to 4, and we color in 4 because it's greater than or equal. So that is graphed. Okay. We should probably talk a little bit about why we reverse that sign when we multiply or divide by a negative number. And let's see if this makes sense. Let's just say you had an actual, we'll just put in some actual numbers. 3 is less than 10. That's true. But what if we multiplied both sides by -1? Okay, so we'll take -1 times 3, and we'll take -1 times 10. So now this is going to be -3, and it's going to be -10. And on the number line, of course, -3 is greater than -10, right? So the less than would not stay the same. We multiply both sides by the same number, but it was a negative number. So less than is now wrong. It's now greater than. And you kind of think about it, that's what -1 does. Multiplying by -1 will take the opposite of each number, and whichever one used to be smallest is now going to be biggest because we took the opposite of both numbers. And any time you divide or multiply by any negative number, you're actually multiplying or dividing by -1. You could think of it that way because you could factor a -1 out. And if you're not sure what that means, that's okay, because I think really the idea is kind of there. If we just talk about -1, it's going to happen with any negative number. It'll swap it. It'll change the direction. If it used to be less than, it'll be greater than. If it used to be greater than, it'll be less than. So that's why it has to be that way. So this is the last one. And this is another compound inequality. This is not or. This is one, sometimes it's called two-sided or bracketed. We've just got an expression in between two other expressions, and we're saying, well, the first one is less than or equal to the one in the middle, which is less than another one. But this is actually an and. This is a compound inequality because we're saying 6x minus 3 is less than or equal to 7x plus 3, and 7x plus 3 is less than 6x plus 10. So there are other types of ands where none of the expressions are the same. Let's write this out as an and I'll show you what I mean. So this is 6x minus 3 is less than or equal to 7x plus 3, and 7x plus 3 is less than 6x plus 10. Okay. Seems like I've lost my scroll bar and I don't know why. There it is. Okay. And now I'm too big. There we go. This may not be, well, okay, I got enough room. I'm good. Okay. Okay, so we have these two inequalities joined by and. That's compound inequality. 7x plus 3 is in both of them. That's where we also will have compound inequalities where you don't have an expression in common between the two. You don't have to have this 7x plus 3 in both of them. This one does, but you know, plenty of them don't. It doesn't really matter as far as how you solve it. When it does have that, there could be a shortcut you could take. We're not going to worry about it. We're just going to do this straightforward way without trying to take advantage of the fact these are the same or anything, because you will see the other ones that does not have an expression in common. So it's similar to what we did with or. We just work with these separately and work them both out. But then we have to deal with the word and instead of the word or. Okay, so let's subtract 6x from both sides of this one. Okay, so 6x minus 6x just leaves negative 3. And 7x minus 6x, that leaves x and plus 3. Okay, so now we're going to subtract 3 from both sides to get the x by itself, right? So on the left we have negative 3 minus 3. And on the right we have x plus 3 minus 3. Subtracted 3 from both sides. The left, this looks tricky, right? No, what's going on? The left is not 0. Negative 3 minus 3, that's negative 6. On the right we have x. And we got there, but we will switch it around. So instead of saying negative 6 less than or equal to x, we'll say x greater than or equal to negative 6. Okay, make sure you're careful. If you flop those around, you have to also switch the direction. In this case, from less than or equal to greater than or equal. Okay, so let's do the other one. We'll subtract 6x from both sides. On the left, it leaves x plus 3. On the right, it leaves 10. Now, subtract 3 from both sides. And that gives us x. And that's less than 7. Okay, so we got this and here. So that's what we get. X greater than or equal to negative 6 and x less than 7. Now this is a different situation than the or. On the or, we colored in everything that made either one of those true. Okay, so we colored, in the case of v less than or equal to negative 10, we just colored that in. And the other one, v greater than or equal to 4, those also make our compound inequality true. So we colored those as well. Whatever makes either one of those true makes the compound inequality true because the compound inequality says or. Just needs to have one or the other. But in this case, this is an and. So here's our original line, our and, right? Which was just a rewriting of the original problem, which was like a bracketed one. It had the 7x plus 3 in the middle. Rewrote it as an and. It's an and already at the beginning, but we rewrote it in a way that makes it more clear that it's an and. So we want to graph this, and that's with the understanding that we want to only graph the points where both of those things are true. So we look at our number line, and we only want where x is greater than or equal to negative 6, but it's also less than 7. So it's going to be between those two, correct? In fact, we could rewrite this as putting an x right here, and it's less than 7, but negative 6 is less than or equal to it. And you don't have to write it that way, but see, if x is greater than or equal to negative 7, that means, x greater than or equal to negative 6, then negative 6 is less than or equal to x. And x is also less than 7, so we can write it in the middle similar to what the original problem was. This makes it clear x is bracketed. But without writing it that way, you can already tell x is bracketed just by looking at the AND result that we had. Well, because it's bigger than -6, greater than that, and it's also less than 7. So it has to be between the two. So here they are. And there it is. Another way people think of this is you can draw these in separately, like sort of above. And let's look at x greater than or equal to -6. And let's just draw that in above. Okay, there's the -6. We want everything greater than that. Now we're not worrying about the AND part yet or the other part. We're just worried about the first part, x greater than or equal to -6, and that's it. I shaded it in. I just colored it up above. And then we can look at the other one, x is less than 7. Okay, well, that does not include 7. We'll do it up above here. But it's everything less than 7, so that's everything here. Okay, so that's what we get when we just consider that second one, x less than 7. But the problem stipulated that it's AND, right? And that's what we got. They have to both be true. So if it has to be greater than or equal to -6 and less than 7, it's the overlap between the two graphs that we drew up above. Where do they overlap? That's where both are true. Okay, and that's the ones we want. Well, it overlaps in this area here. Between there and there is our overlap. Okay, and that's what we drew in down here with the 7, with the circle for 7 and dot for 6. We had already done that just thinking about it logically, but we could also draw those two and show the overlap. Okay, so that's an AND. We just did one OR and we did one AND. Not a whole lot of examples, but you'll have some more to work on in class. So I will see you there.